In this class, we're going to talk about limit of a function. What exactly do we mean by limit in differential calculus? Limit refers to the number that the output of a sequence approaches as the input increases without a bound. Okay, that is what we call the limit of a function. Now, this implies that when you take the limit of a function, the function is going to have a value. That value is what we call the limit of that function. You understand? Okay, now, there are two types of limits. You understand? We have finite limit and infinite limit. We have two types of limits. There are finite limit and infinite limit. Now, when the limit of a function, when you take the limit of a function and the function and you have a significant value, that type of function is what we call that type of limit is what we call finite limit. You understand? Now, when you take the limit of a function and you discover that immediately you insert the variable that you are given, you discover that the function increases. You understand? That type is what we call diverge. That means that that function diverge when you take the limit, and that type of limit is what we call infinite. You understand? Okay. Now, having understand the types of limit, let's look at example of each type. Consider the function f of n. Please pay attention. Consider the function f of n is equals to 1 over n. Take the limit, find the limit of the function fn equals to 1 over n as n approaches infinity. You understand? Let's say you are asked to take the limit of this function. Now, don't forget the definition of limit. The numbers, the values that a function approaches. When we substitute the value of our limit, you understand, our limiting value is what we call the limit of that function. You understand? Now, and I told you that we have two types that we want to test. Maybe this is a finite or infinite limit. You understand? I told you that finite limit, they converge. You understand? They tend to approach a value, but infinite limit, they diverge. You understand? And what I mean by diverging is that the function increases when you take the limit of the function. Okay, that type of limit is what we call infinite limit. Now, let's look at the function on the board. F of n is equals to 1 over n. Now, because infinity is not it doesn't have a value. You understand? Let's assume that the value of infinity is large, maybe 1 million. You understand? Now, if you substitute the value of n as 1 million here, you're going to have 0.00 something. You understand? Now, you will discover that no matter the value of n, no matter how large the value of n, this function will not be equals to 0. You understand? But because we have infinity, and infinity is not and it doesn't have an actual value. You understand? So let's take the value of n as a large number, just like 1 million. If you substitute 1 million in this function as the value of n and you take the limit, you're going to discover that you're going to have a value that tends to 0. You understand? That kind, because it approaches 0, that means that that limit converge. You understand? The limit converge to 0. You get what I'm trying to say? Okay, listen. We have finite, infinite. Okay, now if you substitute the value of n as 1 over, let's say 1 million, you will discover that you're going to have 0 point, okay, you can see that the limit tends to approach 0, but it is not equal to 0. Likewise, if you substitute any larger value higher than 1 million, you're going to discover that the limit will tend to approach 0, but it will never be equal to 0. Now, that because the limit tends to approach a value which is 0, that is what we call finite limit. You understand? So, a finite limit, please pay attention. A sequence that has a finite limit, we say that it converges. You understand? It's converged to 0. You understand? Example is this kind. This limit converge to 0, so we can call it a finite limit. You understand what I'm saying? Now, let's say we have another function, f of n. F of n is equals to n plus 1 all over n. Now, we are asked to take the limit of n as n tends to infinity. Okay? Now, we are asked to take the limit of n and as n tends to infinity. Well, before we can take the limit of n, we have to manipulate the function, you understand, by dividing by the highest power of the variable that is at the denominator, you understand. The variable in the function is n, and we only have n at the denominator. So for this, I'm going to take, before I take the limit, I'm going to have something like this, n all over this n that is at the denominator, n all over n plus 1 all over n all over n over n. You understand? You see, let me revert back to this. The limit of this function is 0. You understand? That is why you often see that when you take the limit of a function that looks like this, you always have 0. It is because because infinity doesn't have an actual value. You understand? And if the value is large enough, the value, no matter how, it might not be 0, but it tends to 0. So most often you often see that if you take the limit of a function like this, you are going to have 0. Do you understand? Okay. Now, for the second one, the reason why, please pay attention, you cannot substitute the value of n as infinity directly, because I told you infinity doesn't have an actual value. You get what I'm trying to say? So that is why we have to manipulate the function. What do? I just divide by the highest power of n, which is at the denominator. And because I have only n here, that is why I divide by n. You understand? Assuming I have n plus n squared, I'm going to divide by n squared. You understand? So I'm only having n, so I divide all the numerator and the denominator by n. So I'm going to have something like 1 plus 1 over n all over n over n. Now, from this we know that if you take the limit of 1 over n, you're going to have what? N over n is also the same thing as 1. If you take the limit of 1 over n, you're going to have 0, right? So for this, I'm going to have 1 plus 0 all over 1, which is what? 1 over 1. Now, 1 over 1 is equivalent to 1. Is that not it? Yes. Now, this kind also is a finite limit. You understand what I'm saying? So, a finite limit is a limit that converges. You understand? What I mean by converging is that the limit, that function tends to approaches a value. Are you getting what I'm trying to say? Now, when you take the limit of this function, it tends to 0. We got 0. You understand? Okay? When you take the limit of this, you get 1. You understand? So, both of them approaches a value, which that's why we call them finite limit. You understand? Now, I want you to, let's say, please pay attention. Let's say we have another one, f of n is equals to 0.1 to the power of n. As n, take the limit of this function as n tends to infinity. What will be the limit of the function that you see on the board? Well, it's simple. If you take the limit of this function that you see on the board, as n approaches infinity, you are going to have 0. You understand? Because 0.1 means 1 over 10. You understand? And if you take the limit of 1 over 10, okay, let's try it. 0.1 raise n, set n as any larger value. You understand? Because you know infinity doesn't have infinity, which is this sign, doesn't have an actual value. You understand? So just imagine a very large number such as 1 billion. So put n as 1 billion here. 0.1 raised to the power of 1 billion. You will discover that you're going to have 0.0000. Are you getting what I'm trying to say? The value tends to 0 as well. So the limit of this function will be 0. You understand? So that is it. And this kind also is a finite limit. The reason is because it converges. You understand? It tends to it approaches a value. You understand? The function approaches a value. Are you getting what I'm trying to say? Okay. Now, having understand what is meant by finite limit, that finite limit converge because they tends to 0. Now let's look at infinite limit. Okay, infinite limit. Infinite, if the limit of a sequence doesn't converge, you understand, such limit is said to be infinite limit, you understand. Now if it doesn't converge, that means it's diverge, you understand, and that is why I put into bracket any limit that diverge is what we call infinite limit, you understand. What I mean by diverging is that the limit, you understand, the function increases, it becomes larger when you take the limit of the function. That kind of function is what we call infinite limit. You get what I'm trying to say? An example is, I'm coming. Let me erase this. Let me erase this. Let's say we have f of n. F of n is equals to n squared plus 1. N squared plus 1 all over n. Okay, now we have to take the limit of this function. Okay, now as n approaches infinity, now to take the limit of n of this function as n approaches infinity, because infinity is not actually a value, you understand, it's just a it's not a value, so we have to manipulate this function. What are we going to do? You divide both the numerator and the denominator by the highest value at the denominator, you understand. Now because the highest value of the variable, the highest power of the variable at the denominator is what? N to the power of 1, which is n, you understand. So I'm going to divide both the numerator and the denominator by 1. Do you understand? Okay, that means I'm going to have n squared all over n plus 1 all over n all over n over n, you understand. So for this we're going to have n plus 1 all over n over n is what? Oh, sorry. Zero. Because 1, remember that when we take the limit of 1 over n is what? It is 0. You understand? From the previous example that I showed you. Okay? So n plus 0 all over n. N over n is what? 1. So I'm going to have n plus 0 is what? N. N over 1 is also the same as n. So now, if you substitute any value of n into this, you are going to have the function is also going to increase. You understand? It's not going to decrease. For example, let's say n is 1 million. The function will become 1 million. Now, because n is infinity, because n tends to infinity, you understand? We are asked to limit this function as the value of n tends to infinity. So the limit of this function will be infinity. Because if you put any value as n, you are going to get the value again. You get what I'm trying to say? As the value of n increases, as the limit increases, the function itself increases. This kind of function is what we call infinite. You understand? Infinite limit. This kind of limit is what we call infinite limit. Do you understand? Okay. So having understand what is meant by limit and the types of limits, which are infinite and finite, we can now proceed to rules of limit. You understand? There are rules that guide, that help us in understanding how to take the limit of a function. Okay, now the first rule, before that, I want to tell you something. Limits can be manipulated algebraically according to the following rules. Number 1, the multiplication of a constant. Okay, the multiplication of a constant. That's the first rule. Okay, you are done with this, right? Yeah, okay. Now let's proceed. The first rule is the multiplication of a constant. Now, rules of limits. Okay. Now, let's say, please pay attention. Let's say f of n. Let's say limit of f of n as n tends to infinity is equals to f, and limit of g of n as n tends to infinity is g. Now, based on what we have here, please pay attention. See, f of n and g of n, they are functions. You understand what I'm saying? And when n tends to infinity, we want to look at how these rules works for any function that we are taking its limit. You understand? So we represent any function will come in this form. Are you getting what I'm trying to say? So we want to look at the first rule, which is the multiplication of a constant. You understand? That rule states that the limit of an expression multiplied by a constant is the product of the constant and the limit of the expression. Listen to the explanation again. I'm going to take it one by one. Just pen it down, okay? Now, the limit of an expression multiplied by a constant, okay? Now, let's take the multiplication rule. Multiplication of a constant. Okay? Now, according to this rule states that the limit of a constant multiplying the limit of an expression multiplying a constant is equals to the product of that constant and the limit. You understand? Now, that means that if I have limit of, let's say we have a constant can be any number. You understand? It can be 10, it can be 12, you understand? But I'm going to represent it as k. You get it? So let's say we have limit of k multiplied by a function fn. A function fn as n tends to infinity. You understand? Let's say we are asked to take the limit of a function that looks like this. You understand? Now, k is a constant and fn is a function. You get what I'm trying to say? We are asked to take the limit of this kind of function according to the multiplication of a constant rule of limit. The limit of an expression multiplying a constant is equals to, please pay attention, is equals to the product of the constant and the limit. Do you know the meaning? That is, when you take the limit of this function, the value that you get multiplied by the constant will give us the value of this expression, what we have here. You understand? That is what the explanation is all about. The limit of an expression multiplying by a constant. What is the expression? The expression here is what? Fn. Multiplying a constant. The constant here is what? K. You understand? So when we take the limit of a function that looks like this, the multiplication of a constant rule of limit states that we are going to have, now because we have already said that let the limit of, if we take the limit of a function n as n tends to infinity, we are going to have f. This is just an assumption, you understand? So because for any limit of a function that we take, we are going to have a value, you understand? So now let's say that when we take the limit of this function, we have f. The final answer to this question will be k, which is the constant, multiplied by limit of function n as n tends to infinity, which is what? Now, because we have already said let the limit of f of n as n tends to infinity equals to f, we are going to have k multiplied by f, which is what? Kf. That is the multiplication rule. Do you understand? The limit of an expression multiplying a constant is equals to the product of the constant and the limit. Okay? The limit of an expression multiplying a constant is equals to the product of the constant and the limit. You understand? Now, because we said let this limit equals to f, that means I'm going to have k multiplied by f, which is kf. Now, that is the first rule. Now, let's look at the second rule. So, I want you to try this. Before we move to the second rule, I want you to try this. Let's say we have limit function gn, okay, limit, I am planning to use a red pen so that you can actually be able to distinguish. Okay, as n tends to infinity. Let's say you have to take the limit of a function that look like this. What will be the limit? Okay, quickly solve that question. The limit will be c multiplied by now, because I've already said let the limit of the function g of n as n tends to infinity equals to g, I'm going to have c multiplied by g, which is equals to cg. Now, these are just rules. You understand what I'm saying? Okay. Now, let's look at I want to give you an example of the application of the rules that you just learned. Okay. So quickly write this so we can proceed. Okay. Let me give the. I want you to try this. Try this. Find the limit of you are asked to find the limit. I want to show you the application of the law that you just learned just now. Okay. Now let's say you are asked to find the limit of this function as n tends to infinity. How do you find the limit? Well, you can factorize. You understand? Because you can factorize. I want to explain the meaning of what you just learned now. Okay. Now, factorize. You're going to have lim as n tends to infinity 2 over 3 multiplied by n plus 1 all over n, right? Okay. Now, according to this law, the limit of a constant, the limit of an expression multiplying a constant is equals to the product of the constant and the limit. You understand? Now, if you can see that 2 over 3 is just like a constant, just like the value of k that we have here. And we told and we learned that if you have a function that looks like this, the limit will be k, which is the constant. So the limit of this function will be 2 over 3 multiplied by, now because infinity is not doesn't have a value, you know that we're going to manipulate, you understand, by dividing this function by the highest power of the numerator. You understand? Listen to the explanation. It's simple. Okay. Now, when I start this class, I take the limit of a function that looks like this. If you take the limit of n plus 1 all over n, you're going to have 1 plus 1 over n all over n over n. Now, just like what we did earlier, have you forgotten it? Aha, don't forget. So, if you take the limit of this function to infinity, you're going to have 1. You understand? So, that means that 2 over 3 multiplied by 1 will give us 2 over 3. That is the final answer. Do you understand? Okay? Now, that is the application of the multiplication of the constant rules of limit. Now, let's look at another rules. The second rule that we're going to talk about is the sum and differences. You understand? The sum and differences. According to this rule, the limit of the sum or differences is the sum or differences of the limit. Don't worry, I'm going to explain. I'm going to explain. Now, quickly write this so we can proceed. Okay, let me erase this. Okay. Now, this example that you saw that I did here is just an example of the first rule, which is the multiplication of the constant. You understand? Maybe you forgot how I take the limit of this. You can reverse video and listen to the explanation again, okay? You understand? So now let's move to the second rule, the sum and differences. That's the second rule, the sum and differences. Okay, now according to this rule, I told you that the limit of a sum or differences is the sum or differences of the limit. Now let's say you have a function let's say you have a function limit f of n. Now we want to talk about sum. Now we want to talk about sum. So limit f of n plus g of n as n tends to infinity. Now according to this, you can see that the sign between function fn and function gn is what? Additional sign. That means it is sum. You understand? So now according to this rule, the limit of this function is equals to the sum of the limit. That means I'm going to have lim f of n as n tends to infinity plus limit of function g, okay, function g of n as n tends to infinity. You understand? So that is the basic idea behind the rule. Now, because we have already said that let the limit of a function let the limit of f of n as n tends to infinity equals to f, and the limit of function g of n as n tends to infinity equals to g. So we are going to have f plus g. You understand? We are going to have f plus g. Okay. Now, according to the difference, we are moving to difference now. Difference means subtraction. You understand? So let's say we have limit of a function f of n minus limit of function g of n as n tends to infinity. That means we are going to have limit f of n as n tends to infinity minus the limit of g of n as n tends to infinity. That means I'm going to have f minus g. Okay, so that is the basic idea between the sum and differences rules of the limit of a function. Okay, now let's look at example. Let's look at example of what we learned. Okay, let's say you are asked to, please pay attention. Let's say you are asked to take the limit of this function. Limit n plus 1 all over 5n, okay, minus 1 over, okay, minus 6 over n rather, minus 6 over n as n tends to infinity. Okay, let's say you are asked to take the limit of this function. Well, how do you find the limit of this function? It's simple. All you have to do, the sign between these two functions is what? A subtraction sign, which is difference. You understand? So you go back to the rules of limit, that the limit of the difference is the difference of that limit. You understand? So the limit of difference between two functions is the difference between the two limits. So we have to take the limit of each of the function individually. Okay, so for this I'm going to have something like this. Limit of n plus 1 all over 5n as n tends to infinity minus the limit of 6 over n as n tends to infinity. Now you see this question here that you see here, I can rewrite, please pay attention, according to the multiplication of a constant rule that we learned earlier. You know, multiplication of a constant is also part of the rules that applies to limit. You understand? So I can rewrite this limit as 1 over 5 limit of n plus 1 all over n as n tends to infinity. You understand? So now don't forget that n plus 1 all over n, the limit is what? Is 1. You understand? So we've done it. If you take the limit, if you take the limit of n plus 1 all over n as n approaches infinity, you know that we're going to get 1. You understand? So I'm going to have, for this, I'm going to have 1 over 5 multiplied by 1. Now I'm dealing with the left hand side, you understand, which is this one. Now for this, I'm going to have limit of 6 over n. Pay attention. Limit of 6 over n will be 6. Limit of 1 over n as n tends to infinity. You understand? Now don't forget that if you limit 1 over n, the limit of 1 over n is what? 0. You understand? When I started this class, I explained what it means, the meaning of this. You understand? And the value will tend to approach 0. So we set 1 over n, the limit of 1 over n as n approaches infinity to 0. You get what I'm trying to say? So for this, I'm going to have minus 6 multiplied by 0. Okay? So that means I'm going to have 1 over 5 minus 0, which is what? 1 over 5. Okay? That is the limit of the function. Okay? I'm very sure you understand. That is the limit of the function. The limit of this function is 1 over 5. If you still don't understand, maybe you should kindly reverse the video. Okay? Kindly reverse the video. It's simple. Okay? So that is the limit of the function. And if you want me to reiterate, you can let me know in the comment section. Now, so you can see the application of the difference now. The limit of the difference of the function is the difference of the limit of that function. Okay, and that's the rule that we apply here. So I will give you another example that I want you to try. That one will be based on sum. Okay, let's say you are asked to take the limit of this function. Let's look at sum. Okay, let's say you have to take the limit of 7. Okay, limit 7 over n. 7 over n. Okay, 7. Oh, sorry. 3 over 7n. 3 over 7n. 3 over 7n plus 4n plus 4 all over 5n as n tends to infinity. Now, look at this question. You can see that the sign between the function that we have in the bracket is an additional sign. So we use the additional rules of the limit of a function. And how do we go about that? Well, according to this rule, the sum of the sum of a function is the sum of the limit of that function. Okay, so we just approach it just like we did for the differences. So for this, I'm going to have limit 3 over 7n 3 over 7n as n tends to infinity plus limit 4n plus 4 all over 5n as n tends to infinity. Now, for this, I'm talking about this now. I'm going to have, according to the multiplication of a constant, you can factorize 3 over 7 out. So I'm going to have 3 over 7 limit 1 over n as n tends to infinity, as n approaches infinity. And for the second one, please pay attention. You see 4 over n, 4n plus 4 all over 5n can be written as 4 over 5 into bracket n plus 1 all over 5. all over n. It's just like I factorize 4, then I bring 5 outside, okay? So for this, I'm going to have 4 over 5 limits of n plus 1 all over n as n tends to infinity. Do you understand? Okay? Now, from this point, we can actually take the value of the limit. If you limit 1 over n as n tends to infinity, what will be the answer? The answer will be 0. You understand? Okay? So I'm going to have here 3 over 7 multiplied by 0. Okay? 3 over 7 multiplied by 0 plus. Okay? Now, we're going to have 4 over 5 multiplied by. Now, if we take the limit of n plus 1 all over n as n tends to infinity, you're going to have 1. You understand? So I'm going to have this multiplied by 1. Okay? And if you are not sure, you can take the limit by yourself. To take the limit of a function that looks like this, all you have to do is that just divide both the numerator and the denominator by n, just like what we did in in the previous example. So the final answer to this question is what? That will be 4 over 5. Okay? The limit of the function is 4 over 5. If you get it correctly, kudos to you. Okay, so that is the application of the sum. You understand? Now, there are many other rules, you understand, that we're going to talk about. But before that, I want to try this question. It's also on the sum of the limit. I want to try this question. Evaluate the limits. I want to try this question. Evaluate the limit as n tends to infinity. Okay, I want to try this question. Okay, make sure you try it and let me drop your answer in the comment section. That's the work. I want to try it. Just approach it. Do it using the method that I use here. You're going to arrive at the right answer. Okay. Now, having understand the sum and the differences law, let us move the product and the quotient. You understand? The product and the quotient law. Okay. So I'm going to erase this. The product and the quotient. The product and the quotient rules of limits. Okay. Now let us start with the product. Okay. Let us start with the product. Now, according to the product rules of limits, the limit of a product is the product of the limit. That's the rule. You understand? The limit of a product is the product of the limit. So let's say you have, please pay attention. Let's say you are asked to find the limit of a function that looks like this. Limit f of n, g of n as n tends to infinity. This will be, now according to this rule, the limit of a product is the product of the limit. That means we're going to have limit f of n as n tends to infinity multiplied by limit of g of n as n tends to infinity. So now, because we said let the limit of f of n as n tends to infinity be equivalent to what? F. So I'm going to have f multiplied by, now limit of g of n as n tends to infinity be equals to g. I'm going to have g. So this will be what? Fg. Okay? That is the final answer. That is the, we are dealing with the rules now, okay? So that is the rules for the product now. Now, according to quotient, please pay attention. According to quotient rules of limit, The limit of a quotient is the quotient of the limit. It's simple. The limit of a quotient is the quotient of a limit. Let's say, now this one is for products. You understand? Now let's look at the quotient rules. The quotient rules of limit. The limit of a quotient, f of n all over g of n. Quotient means division. You understand what I'm saying? So as n tends to infinity, what will be the answer? The answer will be limit of f of n. Sorry. The limit of f of n as n tends to infinity all over the limit of g of n as n tends to infinity. You understand? Now, because we have already said let the limit of function fn as n tends to infinity be equals to f, so I'm going to have f all over the limit of function gn as n tends to infinity be equals to g. That will be f over g. Okay? Now, you can see the differences. The first is the product rules of limit, and the second is the quotient rules of limit. You understand? Okay? Now, let's look at some application of this rule. Let's say you are asked to evaluate. Okay, what's the answer to this question? Well, the answer to this question is 1. Okay, the answer to that question is 1. If you got it right, that is, the answer is 1. 1 is correct. If you got 1 as your final answer, you are correct. And if you didn't get 1, that means you have to try again. Okay, now, let's proceed with our work. Let's say you are asked to find the limit of a function. Find the limit of this function. Because of space, let me please pay attention, okay? I want to shape this small. Okay. Find the limit of the function n plus 1 all over n multiplied by 1 over n. Okay, as n tends to infinity. Now, looking at this function, which rules are we going to employ? You employ the product rule of limit. What are you going to do? You're going to have something like limit of n plus 1 all over n as n tends to infinity plus the limit of 1 over n as n tends to infinity. Is that not it? Now, if you limit n plus 1 over n as n tends to infinity, you are going to have, oh sorry, this should be multiplication, okay? Because we are dealing with product. Now, this should be multiplication, okay? So, if you limit n plus 1 over n as n tends to infinity, you are going to have 1, right? Yes. That means I'm going to have 1 multiplied by. Now, if you limit 1 over n as n tends to infinity, if you limit 1 over n as n tends to infinity, that will be what? 0. You understand? Because I told you when I start this class that 1 over n, because infinity, we assume that is a large number and it doesn't have an actual value. That means that the function is not going to attain 0, but it's not going to be 0, but it's going to approach 0. You understand? It's going to tend to 0. That means that the value of 1 over n is what? 0. When we set n to infinity, okay? As n approaches infinity. So I'm going to have 1 times 0, which is what? 0. Do you understand? Okay, now I want to do something now. I did the I'm done with the products now. Now let's look at another example on the quotient. I want to try this. I will give you an example. I'm going to give you a work example on the quotient. What will be the limit of n plus 1 all over n divided by 1 over n. What will be the limit as n tends to infinity? What will be the limit of this function? When you are done, you can drop your answer in the comment section. Okay? The final answer is also 1 over 0. And 1 over 0 is what? Is undefined. Okay, let's consider the following question on product and the quotient rules of limits. We are asked to take the limit of this function as n tends to infinity. Now, in this case, we are going to apply the quotient rules of limit. Now, according to quotient rules of limit, we are going to have this limit will be equivalent to 3 minus 4 all over n as n tends to infinity divided by limit, please pay attention, divided by limit of the denominator now, that will be 2 over n as plus 5 as n tends to infinity. Okay, now if you take the limit of 3 minus 4 over n as n tends to infinity, you are going to have 3. I hope you know that. Well, let me explain. You know that when you take the limit of 1 over n, any numbers over n as n tends to infinity, that limit will be 0. You understand? Because I told you that no matter how large the value of n, the limit, the function will converge when you take the limit to infinity. You understand? So we have 4 over n. 4 is also a number. 4 over n will be 0. You understand? And 3 minus 0 will be what? 3. You understand? So I'm going to have 3, which is the answer here. 3. Now, for the second limit, we have 2 over n plus 5. 2 over n will also be 0. You understand? When you take the limit of n, when you take the limit of the function 2 over n plus 5 as n tends to infinity, you are going to have 2 over n will be 0. That will be what? 0 plus 5. 0 plus 5 is 5. Okay? And because we have a division sign, and the quotient of a limit is the limit of that quotient. You understand? The limit of a quotient is the quotient of the limit. You understand? So for this, we are going to have 0 plus 5, which is 5. And because there is a division sign, which is the quotient sign, I'm going to have 3 over 5, okay, as the final answer. So the answer to this question is 3 over 5. Okay, now for the second question, we have the limit of 7 over n minus 4 multiplied by 6 plus 1 over n as n tends to infinity. Now, we have 7 over n minus 4. What will be 7? Well, you can just write it out. Just write it out. Limit. If you are solving this in theory, you understand, you can just put it like this. Put it in this form. 7 over n minus 4 multiplied by, because the limit of a product is the product of that limit. You understand? So it's just the same thing I'm doing. So for this, I'm going to have 6 plus 1 over n as n tends to infinity. For this, here I'm going to have now 7 over n. If you take the limit of 7 over n, you're going to have 0. You understand? And because 4 does not have an n attached to it, you understand? This 4 does not have an n attached to it, so we're going to have negative 4 as the limit of this. So I'm going to have negative 4 multiplied by, now, if you take the limit of 6 plus 1 over n, 1 over n will give us 0, you understand? The limit of 1 over n as n tends to infinity will give us 0. You get what I'm trying to say? Now, if you now take the limit of 6, 6 doesn't have an n attached to it, so I'm going to have 6 plus 0. That will be 6. So I'm going to have minus 4 times 6, which is what? Minus 24. Okay, hence the limit of this function as n tends to 0, as n tends to infinity is negative 24. Okay, now I want to try this question. Limit I want to take the limit of this function as n tends to infinity. 7 over n minus 4 all over 6 plus 1 over n. Okay, as n tends to infinity. I want to attempt that question, okay, and drop your answer in the comment section. Now, so that is the solution to the product and the quotient rules of the limit. Now, okay, another rules of limit that we're going to talk about is the power rules of limit. You understand? So, you know, the power rules have many conditions. You understand? These are the conditions that we're going to examine under the power rules of limit. You understand? I put this line so as to know that as to separate each condition from each other. You understand? I separated the condition from each other. That's why I put this line. Okay. Now we have, for the first condition, now we have limit k to the power of n as n tends to infinity. Now for this condition is that minus 1 is less than n, minus 1 is less than n, and n is less than 1. Now, for this kind, the limit of the function is equivalent to 0. I'm going to explain, just pay attention. The limit of this function is equivalent to 0. Now, let's say, don't forget that k is a constant. You understand? K can be 1, it can be 2, it can be 3, it can be 4, it can be 5, 6. Are you getting what I'm trying to say? It can be 10, it can be 1000. Are you getting what I'm trying to say? Now, for the value of k is a constant now, is a number. For negative 1 is less than n less than positive 1. The limit of this kind of function is 0. Now, let's say we have, okay, I'm coming. Oh, this should be k. Now, let's say we have 1 over 3, pay attention. Let's say we have 1 over 3. I'm just thinking of what I can do. I'm thinking of a function I can imagine. Okay, 1 over 3. 1 over 3 is also a decimal. 1 over 3 raised to the power of n. Let's say we are asked to evaluate the limit. Please pay attention. Of 1 over 3 raised to the power of n as n tends to infinity. Now, you know that if you divide 1 divided by 3, you're going to obtain a decimal. You understand? Now, when n tends to infinity, please pay attention. When n tends to infinity, that means n increases in value. You understand? For example, let's say, okay, let's use 1 over 2. 1 over 2 is 0.5. Now, if n increases, maybe n is 1 million, you will discover that 0.5 to the power of 1 million, we discover that the value actually approaches 0. You understand? And I told you that the limit of a function refers to the value that we obtain when we take the limit, when we insert the limiting value. You understand what I'm saying? The value that is obtained as output is what we call the limit of that function. Now, if you take the limit of 1 over 2 to the power of n as n tends to infinity, you're going to have 0, because though we might not actually got 0, but the value tends to 0, so we can say that the limit of this kind of function is 0. So any function that you have, any function that look like this, when n tends to infinity, for the value of k, negative 1 is less than k. Don't forget that k is a constant and k is less than 1. The limit is equal to 0. Now, for the second condition, where k is equivalent to 1, if k is equivalent to 1 and the value of n tends to infinity, this kind of function will always give us 1. You understand? The limit of this kind of function will always give us 1. Example, let's say you are asked to evaluate limit of k. K is now 1. You understand? For k equals to 1, 1 raised to the power of as n tends to infinity. Now, if you have to evaluate the limit of a function that looks like this, your answer will be what? It will be 1. Because 1 to the power of 1 is 1. 1 to the power of 1 million is 1. 1 to the power of 1 billion is 1. 1 to the power of, are you getting what I'm trying to say? So, the limit of a function where k is a constant, I told you, k is a just number. Are you getting it? So, where k is equals to 1, the limit of a function that looks like this will always give us 1. Now, for the third condition, we have the limit of k to the power of n as n tends to infinity. Oh, sorry, I made a mistake. For k is greater than 1. For k is greater than 1. Okay? Now, what will be the limit of a function that look like this? For k is greater than 1, that means that k may be 2, 3, 4, 5, 6. Are you getting what I'm trying to say? So, now, if k is greater than 1, and we limit a function k to the power of n, where n tends to infinity, what will be the answer? The answer will be infinity. The limit of such function will be infinity, and the reason is because when as the n increases, you understand? For example, let's say we have limit of 4 to the power of n as n tends to infinity. Now, because I told you that infinity does not have an actual value. You get what I'm trying to say? Infinity doesn't have an actual value, so we assume a very large value. Let's choose 1 million. Now, if n is 1 million, as we limit n as n tends to 1 million, that means that I'm going to have 4 to the power of 1 million. You are going to discover that the value of this function is going to increase. Is that not it? Now, if n changes to 2 million, you can see that it's going to increase as well. So you can see that this kind of function increases. Are you getting it? So we said that the limit of such function is infinity, because as n increases in value, the function also increases, and this kind of value is the kind of limit is what we call infinite limit. Do you remember? If you didn't remember, reverse the video and listen to the explanation again. This kind of function is infinite limit. This one is finite, this one is also finite. You get what I'm trying to say? So that's it. Okay, now let's look at the third condition, infinity. Now let's look at the fourth condition. We have limit k to the power of n as n tends to infinity. This one is undefined. You understand? Is undefined. Now I'm going to explain. Just pay attention. This one is undefined. The limit of this kind of function is undefined. Here k is less than or equals to -1. Now if k is less than or equals to -1, let's assume that we are asked to take the limit of a function maybe -2 to the power of as n tends to infinity. This is undefined. I'm going to explain. The reason why it is undefined is because, see, if n, let's assume that n is 2, and you substitute 2 here, you're going to have -2 times 2, right? And -2 times -2, that is what? +4. Now, let's assume that n is 3. You're going to discover that the function is also will increase, right? Yes, it will. But the sign will changes, you understand? So, that means that because as n increases in value, the function changes in sign. That means that it is undefined, okay? Because we cannot say that we insert negative infinity or positive infinity. I don't know if you get what I'm showing. Listen to the explanation again. See, when n changes in value, the sign changes simultaneously, okay? And because it happens like that, we are going to call this function the output of this kind of function is undefined. You understand? Because the sign changes repeatedly, okay? So it changes from positive to negative and from negative to positive depending on the value of n. And because n is infinity, and I told you that infinity doesn't have an actual value, so that means the value of n, the value of this, the output of this function is undefined. Okay, so now I'll give you some questions that I want to attempt, and I want to drop your answer in the comment section. I want to attempt the following question. Now I can erase this. Let's erase this. Now let's say f of n is question 1. Let's say f of n is equals to mh I mean lim f of n limit 0.01 as n tends to the power of n as n tends to infinity. Now we have to take the limit of the function 0.01 as n tends to infinity. What will be the answer? The answer will be 0. You understand? The answer will be 0. Now I want to ask, does this limit converge or diverge? It converge. You understand? And this kind of limit is also called finite limit. Okay. Now another example. Take the limit of 1 over 0.1 to the power of n as n tends to infinity. What will be the answer? I mean, for this kind of limit, what will be the answer? The answer will be infinity. And the reason is because 1 over 0.1 is what? On 10, you understand? We're going to have limit of 10 as 10 raised to the power of n. Let me write it. We're going to have limit of 10 to the power of n as n tends to infinity. Now, the answer will be infinity because as the value of n increases, the function also increases. You understand? Now, if the function increases as the value of n increases, that means that this kind of function diverge. You understand? And this kind of function is also called infinite function. Okay. Now, for the third example, let's say we have limit negative 100. Now, this kind is undefined. You understand? It is undefined. It is undefined, and this kind of function is undefined and it diverges. You understand? Okay, it's undefined. Though it's undefined, it diverges because if the value of n increases, the function also increases. You get what I'm trying to say? So that is it. That is all about limit. We're going to look at, you see, the major categories of limits are finite and infinite limits, but there are also subcategories. You understand what I'm saying? For example, indeterminate limits. Indeterminate limit is a kind of limit that has a numerator and the denominator as an infinite limit. You understand? So you can see. So we're going to talk about more about it in our next class. Okay. So make sure that you don't miss the next class. Okay. And also, before you go, don't forget to hit the like button. Also, subscribe to the channel, share the video to your friend, and drop comments in the comment section. Also, if you missed our previous class on limits, make sure you watch those classes to have an elaborate knowledge on this concept limit, because it's very important as far as differential calculus is concerned. You understand? Okay. So that will be all for this class. See you in the next class.